Hi everybody. Welcome to this talk. You're in NIS307. We're going to talk about designing a cloud-native internet edge. We'll talk about how when we build applications, we're going to enable them to be served to our customers in a secure way. My name is Paul Hawkins. I'm with AWS Security, and I have my colleague here.
Hi, I'm Syed Sharif. I'm part of the Control Tower Service team. Excited to be here.
So let's start off with a metaphor. This is kind of where we've come from. We're going to start off with where we've come from. We're going to talk about where we're going, how we're going to get there. And we're also going to talk a little bit about how this feeds into how you protect your data and how you think about a more zero trust approach as well towards the back end of the talk. But this is very much how we started with network security. We had a strong boundary around our stuff. So in this case, we have a moat around our building. And inside of the building, there are a bunch of things that we want to keep just for us, and we want to keep everyone else outside of that boundary. The disadvantage with this is we rely very much on a single control or a single point of control. If you can hop the moat, then you've got a much higher chance of being able to consume what is in your castle. And this kind of moved on to the traditional networking approach. There's a lot of this going on. There's switches, there's firewalls, there's network infrastructure. And typically this was managed by an individual team. We had a group of people, sometimes it was SecOps, sometimes it was a firewall team, and they owned change. And change is a constant in any system, but we had a bunch of workloads that were sitting behind this layer. So a lot of the time, you had to send a spreadsheet or send a request to this team, and they would pop a hole in the firewall, or they would add a route to a route table. And there was friction here, which is not inherently bad. We don't want people making change willy-nilly in our environment. But it also meant that we weren't able to move as fast as we needed to support the applications that we build. It also meant that we had a very monolithic edge, kind of like our kind of singular moat. And that meant that if we had multiple applications sitting behind our edge, we had to kind of aggregate the configuration. If we have a WAF, the rate limiting had to be appropriate for like the multiple different applications that were behind it. And that meant we had to kind of hedge sometimes. So when we talk about building an internet edge, what are we really trying to solve for? It's not just configuring some firewalls. There's a lot more to it than that. So the way I think about it is this. There are four kind of categories that we're trying to solve for in this particular problem space. We want to support multiple different application types in our organization. We may be doing a lift and shift. We may be dropping a 3-tier web application that's sitting behind a load balancer. We may be building a single page application with APIs that are being consumed. We may be building something that's streaming. We want to support all of these different application types. We want to give the builders in our environment the right tools to solve the right problem. We don't want to be super prescriptive in terms of how they solve this problem, but we do want to be very opinionated about what they're solving for. So we want to make sure that if people are using API Gateway, we can support that. If people are using load balancers, either network load balancers or application load balancers, we can support that as well. We also want to be able to see what's going on in our environment. We want to understand our posture. It's no good to just deploy something and say, we've got the configuration, this is cool. We want to make sure that we understand the posture over time. We want to see if things have changed. Because we're going to be giving permission to groups to make changes into the environment because they're best placed, because they're closest to the application. We also want to make sure that when change is introduced into our system, we evaluate this and make sure that it's appropriate, and if necessary, automatically remediate it. And also, we want to do this at scale. We want to do this across multiple environments, multiple AWS accounts, potentially multiple regions. So this is kind of the starting point for our thought process around how do we go and build a modern internet edge. So now we know what we're trying to solve for. What are the capabilities of this edge thing that we're trying to build? It needs to be governed. We need to have a mechanism of ensuring that we can introduce change into the system in a structured and repeatable way and demonstrate to stakeholders, sometimes internal, sometimes external, that we've made good decisions that lead us to these configuration deployments. We wanted to make it observable, not just for the configuration, but we want to also see what's going on in the network traffic that's going through our system. We want to be able to be notified of unexpected or unusual traffic and be able to respond to that. And we want to deliver security at multiple layers. And this is something that's really important. We want to be able to make sure that we are filtering traffic broadly and then moving up the stack. So the capabilities are really important. So I'm going to kind of reiterate these. Governance, how do we get the right configuration deployed in the right place at the right time? And how do we demonstrate that we are doing that? Observability, can we reason about our configuration? Can we deploy the configuration and ensure that's what we expect? And can we get notified to a central security team or to the team that owns the application of unexpected behavior in our network? We're going to have traffic flowing through our network. We're going to have communication from outside coming into our boundary that's hitting our application servers, that's exercising our applications. We want to make sure that the majority of that traffic or all of that traffic is the traffic that we want, and we want to be able to identify if traffic is unusual, unexpected, or undesirable, because this is the thing that's going to be part of our feedback loop into our governance model and into our configuration to make changes into our system. The multiple layers thing, I like to think of as a big funnel. We want to filter as much as possible as far away from our infrastructure as possible, because every time that something hits our application server or makes a call to our database, that's work that we have to do. And if we can filter as close to the client as possible, as close to the internet as possible, we're reducing the traffic at each layer. So these multiple layers work in conjunction with each other to make sure that when traffic hits our applications, it's the traffic that we want to hit our applications. And then moving up the stack is very important. We can, as part of this configuration, as part of these multiple layers, we will be talking about filtering between systems at layer 3 and 4. We're going to have source side ranges. We're going to be saying traffic on this port and this IP address can talk to this port and this IP address. But we want to be able to make some more intelligent decisions. We want to be able to move up the stack and get into the application layer, both for our filtering and also our routing decisions. So what does multiple layers look like? When we say operate at multiple layers, which is one of the principles that's in the well-architected framework security pillar, which you definitely go and have a look at, because there's a bunch of really useful stuff about kind of approaches to networking and broader. But when we talk about multiple layers, let's look at it from inside to out, because this is kind of how we would potentially think about building an application. So we start off with an application in a private subnet in our application VPC. And I'm using the VPC as an example here, but this is actually going to get stamped out multiple times in your environment. You may have multiple VPCs within an AWS account, and ideally multiple AWS accounts to separate your workloads. People separate workloads for a variety of reasons, so you may have separate environments for dev, test, and prod. You may have shared services. The AWS account is a good logical boundary because the permissions have to be explicitly shared outside of that account. So we've got a bunch of instances in a private subnet. Surround these with a security group. This is the smallest unit of network filtering that we can deploy. This allows us to control which traffic can get from which instance to which other instance. Then in the subnet, have network access control lists. This is slightly coarser, and if you think of the kind of lift and shift three-tier web application, you'd have ACLs which would limit traffic from the public subnet, where your load balancers are, into the private subnet, and then making sure that traffic can only go one hop. So our public subnet may have a load balancer, may have NAT gateways that allow us to get out of the public subnet via the NAT gateway. And then we may have a firewall subnet where we're going to drop an endpoint for network firewall. This is where we're going to be able to do some of our additional filtering. So this is moving up the stack. This is, does the traffic look like it's something that we want to filter? It may be a valid request from the upstream network device or from transit gateway that's trying to hit the load balancer, but this is where we're going to do some of our more intelligent filtering based on firewall rules and analysis. Then in front of this, we're going to have an internet gateway because we actually want to be able to service this traffic out to the internet. And because in this particular example, we have an internet-facing resource or an internet-facing application, we want to stick it behind CloudFront. Because CloudFront is our content delivery network that allows us to serve content closer to the clients. It also gives us an amount of protection against volumetric DDoS. And then for more layer 7 protection implemented at our edge, we can associate AWS WAF with our CloudFront distribution. And this allows us to deploy WAF rules that inspects the traffic and provides us filtering at layer 7. But this defense in depth approach, this layered approach, doesn't just apply to workloads running on EC2. We also can apply this concept to API gateway and serverless applications. Now, with Lambda, you can drop an ENI and a VPC and then exist in the world of these network security controls. All of this gives us our opportunity at various points to implement network filtering, from on the most specific on the right of the screen, the security group, out to the most broad at the edge with CloudFront and WAF. If you build using CloudFront, Route 53, API gateway, you take advantage of the global scale of the AWS network. And we do a lot of work to protect the platform when you inherit that layer 3 and 4 volumetric protection. This is delivered via a service which we call Shield. But there is also Shield Advanced, which is basically Shield, but with an additional support construct. It provides you additional fidelity and visibility into the protection that you're getting. It allows you to provide faster mitigation for your applications. You get access to a DDoS threat environment dashboard, so you can see what's going on in the world, and 24/7 access to the Shield response team. So Shield Advanced is a fixed monthly cost, but you get included in that cost for all of the resources that are enrolled into Shield Advanced, which you can do programmatically, web application firewall for no additional cost, which means that you have the ability to get access to DDoS response specialists to help you in the event of an issue, and they can give you guidance around tuning your rules, etc. So this is a really good way of having access to a support construct and moving up to get an additional protection on top of Shield standard. So I'd like to dive into a little bit more specificity around the components in our layered stack. So I'm going to start from the outside and go back in. So we've talked about Shield. AWS WAF is a managed WAF, so there's no infrastructure for you to manage. You can talk to it via APIs or the console. You can associate WAF ACLs, access control lists, with a CloudFront distribution, an application load balancer, or API gateway. You can use managed rules from us, from AWS, that are based on kind of our internal awareness. You can use partner rules, or you can craft your own. Things like built-in SQL injection and cross-site scripting protection. And yesterday or the day before, we announced an update to the SQL injection protection so you can tune the sensitivity. Because one of the interesting things about building a WAF is making sure that you're generating the right amount of protection. And depending on the application, you want to be able to tune that. So we've given you the option to tweak the sensitivity between high and low, and then as you observe the traffic that is going through the WAF, as it's working with your application, that allows you to get tuned to the thing that is appropriate for the workload that you're running. Then we have Network Firewall. Again, it's built for the cloud. It's got a flexible rules engine. You can write Suricata rules, you can write Snort rules, and you can consume managed rules from AWS. You can manage your policies centrally, and it also gives you real-time visibility of the activity that's going through your system. And you can expose this and export this via a Kinesis stream, or export it to CloudWatch to give you visibility and the data to make decisions about tuning your network firewall rules. We've also added a couple of new features to this relatively recently. You can use prefix lists. So when you're building firewall rules, creating source and destination, you can wrap up a bunch of different CIDR ranges or a bunch of different IP ranges in a prefix list. And this could be something that's potentially owned by the security team to say, these are all of the prefixes, or these are all of the ranges in my environment for dev or test or prod. And then when your builders are configuring network firewall in the environment that they know about, they can consume this prefix list, so you've got greater confidence that the rules that they're writing are based on the entire set of network ranges in your environment. A companion to this is Route 53 Resolver DNS Firewall. So this is also kind of a partner to some of the detection capability and services we have like GuardDuty. So it's doing DNS filtering. So the .2 address in a VPC is the DNS resolver, and one of the ways that malware or applications that you didn't intentionally install in your environment communicate out to their command and control locations is via making DNS calls. So you can configure DNS firewall with either allow list or deny lists, but you can also include managed rules from AWS, which pushes regularly updated locations of known nefarious DNS locations. So if you have traffic that's communicating or attempting to communicate out to those locations, it will get blocked, which mitigates some of the issue. You still need to go and investigate, you still need to resolve whatever upstream issues, but it provides you a good preventative control for systems that are communicating out to unexpected locations. You can also, with the configuration that you deploy, set up an allow list to say, this application or this workload should only communicate with these domains, or if you have a list of internal known bad domains, or if you're getting a feed from somewhere else, you can deploy that in DNS firewall to say, deny access to these resources. And then, because we don't want to just do preventative controls, we also want to do detective controls, Amazon GuardDuty. And Amazon GuardDuty is a managed threat detection service that alerts you for unexpected or undesirable behavior or activity in your AWS accounts. This is across kind of the full breadth of the stack. If I have access to an AWS account and I've got a role that I land in as I federate in, and I typically spin up instances in one location, I don't really do much else. If I start trying to create resources with other services, that will flag as anomalous. So I don't normally do this kind of stuff. But also Amazon GuardDuty, it ingests VPC flow logs, DNS queries, CloudTrail logs, merges it with our internal threat intelligence and threat intelligence provided by some partners to give you indications of unexpected network activity. And we released yesterday a component of that GuardDuty malware detection. So when a network finding is generated, say network traffic is identified that's calling out to malware command and control, a snapshot of the EBS volume for that instance is taken and a scan of the files in that file system. And if there is any additional information that gives more information to the security engineer or the person responding around what the malware variant might be, that gets added to the GuardDuty finding. So it gives you a good way of identifying unexpected activity. And then, based on seeing a GuardDuty finding, you can go through the feedback loop and identify if you need to make changes to your preventative controls. Is there something that happened that you would have want to caught with an updated WAF rule? Is there something in your network firewall configuration that you want to tighten up? So you get into this iterative continuous improvement stage where you're getting information from the monitoring tools and the detections, and you're using that to inform your security posture. So now we kind of understand the levers and the tools we have in our toolbox. Let's move on and look at a couple of deployment models. So I'm going to talk about deployment models for WAF and deployment models for network firewall. And you'll notice as we go through them, there's a lot of common principles involved, but this is kind of how in a distributed environment where you have multiple ownership between different teams, you can get the right network configuration to the right part of your environment and have confidence that your baseline posture is being delivered, and then for the builders who own applications, they can provide additional tweaking and additional specificity for the applications that they own. So we start off with this distributed model. So I've got, again, a VPC. There's going to be multiple of these in your environment across multiple VPCs or multiple AWS accounts. I've got an application load balancer sitting in front of some EC2 instances. And I've got an internet gateway so I can communicate with my application in this network. I can deploy AWS WAF at this load balancer. So I can support, in this case, HTTP, HTTPS traffic, and do some TLS decryption at the load balancer. I'm inspecting just at the application layer. This is a layer 7 control, and I can manage this via Firewall Manager, or I can choose to manage it directly by configuring the WAF in the account. So then traffic flows through the internet gateway, hits the load balancer. The load balancer makes a call to WAF to say, is this traffic something that is allow listed or deny listed? And if it is allow listed, it passes through to the instance. You can do the same thing with this pattern and then CloudFront in front of this application. So you've got CloudFront is then passing traffic to your application load balancer, and you can associate AWS WAF with the CloudFront distribution. This is a very good layered pattern. So you've got the pattern on the left, which is owned by the application team, and using identity and access management, you can provide them permission to make changes or to deploy certain WAF rules. But because the application is deployed behind CloudFront and you have WAF rules associated with your CloudFront distribution, you can provide your coarse grain filtering, which is as a security person, I want to make sure that this is the minimum level of layer 7 protection I have for all of the workloads that I build, and then let the application team deal with the things that are more specific for their workload. And again, traffic comes through, hits CloudFront, CloudFront calls out to WAF, the decision is made, WAF tells CloudFront to allow or deny, passes through, hits the load balancer, same as before. The benefit of the first model is that it gives you a lot of flexibility. The principles can be organizational wide, but there are deployments across multiple different parts of your AWS environment. The alternative to this, which sometimes may exist in both cases within your environment. If you have a large environment, there may be some of your workload teams that fit more in the centralized model and some that fit more in the distributed model. So the centralized model here, we've got a bunch of application VPCs that are connected via transit gateway to an edge VPC. So this is where we want to run our edge services. So we've got an application load balancer with WAF associated with it, and all of our internet traffic is coming in through this edge VPC and then is routed through transit gateway to the application, and all of the WAF rules are deployed at the application load balancer within our edge VPC. This is probably very familiar to the networking folks in the model that we talked about right at the very start, where we have a monolithic set of controls, and the control is administered by a team with that particular ownership. If you're not using transit gateway, you can do the same kind of thing. You have an edge VPC with the WAF associated with the load balancer, and you can use private link to drop a VPC endpoint into your edge VPC that routes traffic or connects traffic via private link into the application VPC. Private link is a really good way of having kind of like a one-way flow, so you don't have to connect these with VPC peering. You can just route inbound traffic as appropriate using the VPC endpoints deployed in your edge VPC. And then as we get more going back inside of our environment, we're into network firewall. The deployment models are very similar. We can have distributed security inspection. So you can drop a network firewall endpoint by configuring network firewall rules in each of the VPCs, and that provides filtering from, in this case, the outside world through the network firewall endpoint into the instance or into the load balancer to make sure that only the traffic that is hitting the allow list part of your firewall rules is allowed through. Or you can have a centralized security inspection VPC, and this inspection VPC may be in line with or may potentially even be part of your edge VPC. Plumbing it together with transit gateway, have a network firewall endpoint in your inspection VPC. And this is good because it allows you to do east-west in a centralized place. So if I'm doing traffic from VPC1 to VPC3, that traffic is actually being routed via transit gateway. Transit gateway will flow the traffic through the network firewall endpoint where your decision is made. Should traffic from VPC1 of this type with this payload be able to communicate with VPC3? It also gives you your north-south filtering. So should traffic from the outside world come in through my inspection VPC, routed via transit gateway into the particular VPC that the traffic is designed for. So as you can see, the deployment models allow you to provide a granular level of control for the different pieces of your organization. You can use automation to deploy this, you can use CloudFormation, but we might also want to manage this centrally. We want to make sure that we have confidence that this is going to happen. So what we really want is an easy button. We don't want to have to go to every single account and configure firewall rules or WAF rules or other configuration. We want to be able to do this in an easy, centralized way that makes it easy for our builders, but it also makes it easier for our potentially more centralized security teams. So to do this, AWS Firewall Manager is the tool that you would use. And it allows you to manage AWS WAF, your Shield Advanced, resource onboarding, network firewall, Route 53 DNS firewall, but also manage security groups. So when our builders are building their workloads, we want them to be able to configure the security groups that allows their applications to talk to each other, or the components in their applications to talk to each other. And we want to give them the freedom to do that because they know what their workload or their application looks like. But as part of giving them that freedom, we want to provide them some guardrails to make sure that they don't configure something in an over-permissive nature. And we've talked about defense in depth, and we're going to have layers in our environment. So even if you did configure a security group that was too open, there are other layers that provide you the defense in depth. But we don't want to leave that configuration too open. So with Firewall Manager, you can set policies that say, if a security group changes to have quad 0/0, remove that rule in the security group, or remediate that rule back to a known good state. And the same with network firewall configuration and WAF configuration. When somebody creates a resource, when they create a firewall rule, you can have the firewall rules pushed to the particular configuration in a particular account. So this is the easy button that we have to help you manage all of this. And then Firewall Manager integrates with AWS Security Hub in the same way that Amazon GuardDuty integrates with Security Hub to give you a single place to view the notifications. So when I talked about we wanted to be able to govern this and we wanted to have observability of the configuration, Firewall Manager and Security Hub working together are the thing that allows you to get a view of the posture of your environment. So now I've talked about the network and the network controls that you have access to and the levers you can pull to provide filtering from broad to narrow and centralized management of this. I'm going to hand over to my colleague here, and he's going to talk about how you think about granting access and protecting the data that is across your environment.
Thank you. Thank you, Paul. So let's talk about data perimeters. As we build more and more cloud and put more and more managed services in our cloud, the thing that becomes more and more critical, or the most valuable asset we have in the cloud, is the data. And what we're really trying to protect is the data, right? You don't care about the firewall. It belongs to AWS anyhow. So what you do want to use it, though, for is protecting the data. So let's look at how do we further enhance those network level controls that we just built by using identity as an additional parameter to further get closer to that zero trust network architecture to protect access to our data from bad actors, and also define good preventive controls to get there. Obviously, these are the key objectives. I'll not read the slide, but at a very high level, you want your identities to access resources in your network, and the two other variations of that. And there is some nuance in there, and as we talk about, we'll get in there. For those three objectives, we also have matching three mechanisms for doing that. The first one is service control policies, which allow us to define guardrails for the maximum permissions that can be assumed within our account. Obviously, we have VPC endpoint policies, which allow us to define identities on those VPC endpoints that Paul mentioned earlier, to ensure that the right principals can use those to get to the right resources in our account. And then the resource-based policies, which are attached to certain resources like S3 buckets, KMS keys, to ensure that only the right people can access that resource. So our first objective was only trusted identities can access my resource. So in this example, I have an S3 bucket. And as you can see, this could be a IAM policy or an SCP, which are both identity policies. I put a action that is any of these three actions are denied on this bucket, which is my logs bucket or my data bucket, unless these conditions are met. What is the first condition? The first condition is principal org ID. And that is saying, hey, you can specify the organization ID of your organization in this policy in the condition element. And the beauty is, as your organization scales, grows, shrinks, you move accounts around, you don't have to worry about enumerating all those accounts. The resource org ID automatically does that for you. It says, hey, as long as this principal belongs to my organization, they can come in. The second one is the principal is AWS service. This principal does not belong to your org because this is, for example, CloudTrail, as we can see here. CloudTrail is also right into your logs bucket. So you need to exempt that by saying, as long as the principal is in AWS service, I'm not going to deny you. A lot of stuff here, but we'll keep going. I promise you it will all come together. The next one is my identities are allowed from my network. Now, what are we talking about here? We're saying, hey, I have a corporate AWS account, and on that VPC, in that instance, somebody has non-corporate credentials. And using those credentials, can they access their own resource that they manage or own in a different AWS account that is not part of my corporate organization? In this case, we're using a VPC endpoint and putting a policy on it that looks like this. We're saying, allow this action as long as, again, the condition is the principal is in my org. So in this case, because the non-corporate credentials do not belong to my org, neither can they go to my SQSQ. And when it comes there, it says, oh, you're not in my org. Sorry, I do not recognize your credentials, so you can't go to your own resource either. That's why both those arrows are red here. Then the third one, only my identities can access my resource. Here we have a different principal IAM condition. As you can see, it differs from the principal org ID we talked about so far. And just to make sure again here, if you think about this, where is this policy going? This is again an identity style policy, right? I have the same option here now, but now I have corporate credentials. And I'm saying, hey, as long as resource is in my org, this is a resource I own in my org, then I'm able to do this action. So I can use SQS send message here because I'm using corporate credentials and saying, and the resource belongs to me. Fairly new condition, very powerful, can be deployed in different types of policies. I've seen customers do it in SCPs, identity policies, and such. Again, is also aware of changes of your org as accounts and principals and resources are added and removed from your org. All right, this one, only access my resources from my network. Now we're adding another level of complexity here. So I have my corporate credentials, I have my non-corporate credentials, both in my VPC. And then there is a non-corporate account where there is a resource that they own. Now, what I've done here on my VPC endpoint, as you can see, there is two conditions now, the principal org ID and the resource org ID. The first condition is saying the principal has to be in my org. So in this case, those corporate credentials meet that criteria. The second one says the resource has to also be in my org. Now what that means is like, okay, this principal that is in my org can access this resource in my org only. And that means basically the only true path here is going to be that single green arrow of going using corporate credentials going to the corporate SQSQ that belongs to my org. The remaining three traffic patterns where I have corporate credentials, but I'm trying to access a non-corporate resource in a different org that I do not own or manage, then because the resource does not belong to my org, I cannot hit it. But the principal belongs. So the first condition meets, but the second doesn't. And then the non-corporate credentials, right? Obviously, the principal doesn't meet, neither does the resource meets for the first one. But in the second case, in the bottom VPC, yes, the resource belongs to my org because the principal is the same, but the principal is not in my org, so I'm going to deny it. Excuse me, please. You talk all day, at some point you start needing, your throat needs water very frequently. All right, now this is our last but not least objective. My resources only accessed from expected networks. So what are we talking about here? I have a corporate network, right? The good world that I like, and my corporate AWS account, also my own that I like. Then I have my developer or somebody else in my company who has taken my credentials because somebody put them in GitHub. Hey, who doesn't do that? And now they're trying to access from their own network, coming in and trying to access my resources. So what's happening here? We have a direct connect. So we have private traffic going between our corporate network to AWS, and then we have a VPC endpoint, and so on and so forth. So how does that look like? First one, we're saying, again, I have a principal who's trying to get to a particular, do these actions on these particular resources, and now I have some conditions. The first one is, hey, my source IP. I know the source IP for my corporate network. Put that in. Now I'm blocking traffic that is not coming from my IP, unknown IP ranges. Second one, source VPC. Hey, traffic should only be coming from my source VPC. I don't want traffic coming to that S3 from anywhere else but that source VPC. And then also saying, hey, but remember those exemptions we wanted to put, because we have CloudTrail writing to our bucket, we have other AWS services writing to our bucket. So we're saying, hey, as long as that principal is an AWS service or it comes through an AWS service, for example, Athena being called through Glue, using Glue via AWS service, we're going to allow that as well. And then I'm also saying, hey, I have an on, which is an Amazon resource name, on that, and it has to match a certain parameter. Like, it looks like this. I'm using my paths. So as you can see, we've used multiple controls here in the same policy and made it really, really to say, like, one, my source IP has to be from my network, because I know what that looks like. My source VPC is from my VPC, which is the VPC ID I have. I have a principal. It's either an AWS, I'm exempted AWS principals, or via an AWS service call if I'm using them. And then I'm also making sure that the roles that come through look like a certain type, especially AWS service roles that look like in my account that would be running at the very bottom. Pay attention closely to that path after the role. So obviously this is the, I should have put a camera icon here. This is definitely the one you want to take a picture of. As you can see again, I have the intent. I only want trusted identities accessing my resource. What did I use? I used a resource-based policy, and my primary IAM feature was principal org ID, which said my principals are in my org, and my principal or the principal is AWS service. I'm not going to read you the slide, but as you can see, using a mixture of principal org ID, principal is AWS service, principal resource org ID, source IP, source VPC via AWS service, you can build a very holistic set of controls using resource-based policies, identity policies, including SCPs, and VPC endpoint policies to build a data perimeter. I know that was a lot of information, but I wanted to sit for you for a little bit because, again, in summary, what are we talking about? The edge is no longer the edge as in the mode that we talked about, right? It's a distributed implementation of common principles of these different identity and network principles and services that you can use to implement those. The goal is to deliver a consistent framework that is well governed for all application types that we have running in our environment. We have layers of filtering and observability, right? We're not just filtering stuff. We have observability, which goes beyond monitoring, right? It's not just monitoring and ignoring the alarms. It's about observability that truly helps you debug not just your security issues, but your application issues. And then you're building with zero trust network architecture in mind, where you're using not just the network as the primary mode of enforcing your protections, but also the verified identity, right? To say that, hey, this principal actually is in my org. And that the only way they could have become a principal is by assuming a role in my account, and I have a very good process for how they can get there. And you are using managed services, so you don't have to do the undifferentiated heavy lifting of managing firewall lists and such, and you're benefiting. Like if you have seen the keynote and Steve talked about it yesterday, about when you benefit from using guard duty, it's not just you, it's the whole AWS ecosystem. Somebody sees an indicator of compromise, that's now used to benefit, update a rule very quickly and benefit you as well. I remember talking to a customer about WAF, and they were like, who else uses WAF? I said, a small retail site I heard. I buy a lot from them. It's called Amazon.com. So even what they're saying is used to help. Again, they're also a customer. So, we're using that. This is the metaphor we started with. Never been there. Would like to go there one day. But looks like a nice castle. I would love to have that. Have a nice little moat around it. Once you're past the moat, though, you're in. But maybe you're my friend. But if you're not, then, well, good luck. But that's not the world we live in, do we? I think the world we live in looks like this. What does that look like? That's the Louvre Museum, right? Never been there. I'm sure my girlfriend will make me go one day, but looking forward to that. But it really, really gets me going. When I see that museum has more valuable stuff than that castle ever had or will ever have. That's my bet. I'm not sure about that. Don't quote me. But that has a Mona Lisa. That has a lot more interesting artifacts in it. And any hobo, any person in the streets of Paris can walk in and get there pretty easily. How do they do that? I mean, our workloads, in my mind, are like that. They're very valuable, but they're only valuable because our customers can get there, right? If I build the best next, whatever widget service I have, if my customers cannot get to it, what's the point? So I have to get my customers to get it, and in a manner that enhances trust and is secure and keeps that customer's trust. So if you look at the Louvre now, what do? You go in, there is a physical security check, but it doesn't end there. You go there, after that, like if you look around, you're enmeshed or almost like in a bubble of security when you're in a museum like that. You have security cameras that are observing or monitoring you. You have security guards. You have humidity sensors. I had no idea like how important humidity is to these paintings. So you have humidity sensors, UV sensors, all kinds of different sensors, and all kinds of perimeters. Just because you're in the Louvre doesn't mean you can go to every section of the museum. There are sections that are walled off for you. Just you cannot go as a visitor. But if you have the right entitlements and you are a worker there or a curator there, you have a special badge, identity, you verify it, you have access. So I would like to just leave you guys with that. Thank you so much for coming today. If you want to reach out, connect with us on LinkedIn. That's our QR codes. You can reach it there. And please complete the session survey.